We're continuing our fall 22 test 4 mechanism that we just took. We left off, we're going to start this SN1 that has a lot of E1 products as well. These are all E products. How do I know? How do you know these are E and not SN products? There's new pi bonds in every one of them. Okay, good job. Okay. So carbocation time, and you're going to need a whole bunch of copies of this carbocation. I'm going to draw the carbocation, and I need 7 copies. Why 7 copies? You're allowed the short form in this section of the exam. There is the carbocation. Oh, sad. I won't be able to grab it. Maybe. Why? Got it. Ooh. It's teasing me. It's going to do 8 different things, no? I could have done this a lot faster, huh? We didn't start the video, did we? We started the video, didn't we? Yeah. Here I am doing a lot of twirling and gyrating, and there we go. You need 8 copies, you got 8 products. Guys, on the final, you don't have 8 products. None of the mechanisms on the final that's over 14 points or 12 points, I think, is the list, right? On the list? Yes. Yeah. So you wouldn't have ever this many products. But none of these are hard mechanisms. These are all equal to each other. Okay. And I hope you see product A immediately and product B. So I want this one to become A. You tell me what molecule I need to react with this, what pair of electrons you're going to use, where it starts the arrow and where it ends. So first, I need the molecule that's going to make this into this, other than this molecule, of course. So what's needed that's here, that's not here? The nitrogen with the 2 methyls and the hydrogen, correct? There's a good short form for it, and it just makes a bond to the carbon with the cation. There you got A, right there. B comes from exactly the same, E, the letter E as in epsilon or easy, comes from the same cation. What Greek letter do I need for the H? Don't say alpha. Alpha is where the leaving group was. Beta is the one away. And you need that H. And guys, it is now time to learn elimination if you didn't, because elimination was not done well on the test at all. No, it's a general thing. Grab beta H, make pi. That's the story. You use the same nitrogen you used before. Then we're going to go to E with the same nitrogen as before. Grab H, sigma becomes pi. That's E1. If you're curious, E1. This was SN1. Of those two, SN1's always major, right? But A is not the major product. We're going to do a lot better. Look at the skeleton for B and tell me which group moved in the carbon skeleton, because you got to do that to make B. Which group moved? And I'd really love it if you told me the name of the group that moved. The vinyl. The vinyl used to be here, and it ends up on the carbon that used to have the leaving group, right? Here's your arrow for that rearrangement. And I realized I didn't need 8 copies of my cation. I needed 4. Because for the rearrangements, I'm going to do 2 things with the rearranged cation. It's okay. It's okay to get carried away sometimes. We're not going to go quite yet to our thing. We got the skeleton is now this skeleton. And that needs to become B. Is that right? Yeah, B. The same way we made A before. Nitrogen lone pair H and 2 methyl. And then we need a copy of this cation. Oh, it shifted over to where the phenyl is. That's right. Sorry. My carbocation's in the wrong spot. You correctly pointed that out. Yeah, I moved away from this towards that carbon. That carbon's got a full octet now. Yeah, and it's the pluses here. And I just needed to look at product B to figure that out, right? Duh. Dr. Whitaker, use your brain. B's got the nitrogen on the carbon with the phenyl. So the cation had to be that carbon. I need a copy of the cation again. I'm going to get rid of these guys on the bottom of the screen. There's too many of them. Okay. So, oh, yeah. That went up to the phenyl. Down, up, down. And plus is here. And how do you make F as in Francis and Folly and Frank? I need 2 more rearrangements, so I do need 1 more of these guys. And I need to look at F. F is here, double bond between the phenyl carbon and the one towards the methyl. Where's the H that has to go from this thing? On the carbon with the methyl. You're getting better, guys. You are getting better at it. 1 away from the cation. And that's going to go to F with the same base. The nucleophile is also a base in an E reaction. Oh, doesn't like me way over there. There we go. Okay, so we've done B and F, is that right? B and F, we're halfway there. This guy's got to do something to get to C. What moved to get to C? The phenyl. And you can do that right here. The phenyl takes its electrons and goes next door. And that's going to go to the species here. And the phenyl's over here. Cation's here. Yeah. And that's going to go to C. I can point to C here. Going to use the same nitrogen. And you got C. I need this copied. Phenyl, C, vinyl, propyl, plus. Please look at product G and tell me where the H is. It's almost like we just did the previous one, right? Same carbon has an H, except there's a phenyl on this one and not a vinyl. And that's going to go to G by way of the same base. And we just have to do D and H, which is major. This one. Wow, we got to talk about that. So I just need 1 more cation. I'll move it upstairs a little bit. I got carried away on the cation. What has to move to get this? This is a propyl on the left on the carbon with the methyl, right? There's the propyl. It needs to go next door. And tell me why this is the best cation result possible. Not just tertiary, much better than tertiary. Twice as good. Twice as good as tertiary. It's tertiary, allylic, benzylic. What is it every time you have allylic? Plus 1.5. What is it every time you have benzylic? Plus 1.5. What's the total of all those numbers? Resonance and hyperconjugation. This is part of my answer for, is it part C? B and C. Hyperconjugation. 6-degree stability. And to get to D, same base. It's a nucleophile this time. I need a copy of this cation, and you tell me how to get that last product. Yeah. Is it not this H again? To get to, I can't even see the letter there. The paper in front of it. H needs the pi bond there. Same base. There you go. And I think we did every product, right? Big picture? It's a very big picture. Yeah. Okay. Good stuff.